Hi, everybody. This is Mr. Max with Sankofa Mathematics. So today I'm going to do paper one that was written last year, the high level mathematics paper. So I've also included the link or the code to my Google Classroom for grade 12. You are going to find the question paper that I'm doing there. So you can go and download the question paper and join my classes, as well as there are a lot of other material that you can use to your benefit. And then also I have also uploaded paper 2 of last year, which is going to be a paper that I'm going to upload soon. And then I also will encourage you to subscribe to my channel and also to click the notification bell, as there are quite a lot of other videos that are going to be useful for you. All right, so please download the paper so that you can follow with the paper if you didn't or if you don't have the paper so far. So let's get right into it. So the very first question that we're dealing with here is we have a lake, and we are told that the lake has an area of 63,800,000,000. That's quite a very big number. Square meters. And you're supposed to write this area in square kilometers and then also correct to two significant figures. So, well, let's just go directly into it. So we know that 1 square kilometer eventually give you 1,000,000 square meters. So that means you're going to take this number and you're going to divide that number by 1,000,000. So we have effectively 63,800 square kilometers, which two significant figures become 64,000. The second question, so it took Angela 8 minutes and 45 seconds to solve a problem, and it took Brian 11 minutes and 40 seconds to solve the same problem. You're supposed to express the ratio of Angelica's time to Brian's time as simple as possible. And you then have to write it in the form P is to Q. Now, here's the thing. You have got the time in minutes and seconds, so make them compatible, make them the same. So I'll suggest that you change them all 2 seconds, as I have done here. So eventually I have got 525 over 700, which simplifies to 3 to 4, because we have to write it in that form, where our P is 3 and our Q is nothing but 4. Right, so here you have a question that deals a little bit with money. It says here there's a car hired, and the terms are as follows. You are paying 2,300 Namibian dollars per day. Then 40 kilometers free for each day hired. So if it's 2 days, it's going to be 40 times 2. If it's 3 days, it's going to be 40 times 3. And then the extra distance now, after you take away that 40 that you drive each day, the extra distance is then charged at $25 per kilometer. Right, so here they say Carmen hires a car for 5 days. So that's already 2,300 multiplied by the 5. And then drives a total distance of 350 kilometers. So she drove 350 kilometers, but then you have to take away the 5 times 40, the free kilometers that she doesn't pay. Okay, so this is what I basically did here. So you see I said the total money will be 2,300 times 5 plus, now the 25 is being charged at the 40 times 5, the number of days subtracted from the total distance that she traveled. All in all, you should get 15,250 Namibian dollars, what she's going to pay. All right, so the next question says Denzel hires a car for P days and drives a total distance of Q. So basically, you are looking for an expression so that we can then just find how we're going to charge him. So an expression in terms of P and Q. So let me bring back the previous question of Carmen. Right, so the 5 and the 350 and this other 5 here, they are interchangeable. The 5 being the number of days, so we don't know the number of days that Denzel hires the car. We also don't know the total distance in terms of Q, the kilometers traveled, this 350 I have here for the previous person, Carmen. So if I bring those letters in and I replace those numbers with those letters, all right, and I go ahead and I simplify this story, I will eventually end up with 1300p plus 25q. So I suggest you pause, try this question, and then see that you simplify, because your answer should be in the simplest form. 1300p plus 25q. Right, so we are rushing in the beginning because there's quite a lot of slides, and I want you to really pay attention and pause when you get stuck in the given question. Right, question 4 says that you are given that x, the quantity x, is equal to 2h minus 1. So when you come to this expression and you are supposed to substitute in for x and for y, so this whole 2h minus 1 will get in the place of the x. And then the y value, which is h upon 3 plus 1, is going to be then substituted here where you have y. This is basically what I have done here. So now you just have to simplify and multiply out and collect like terms. So eventually you should end up with 3h minus 9. Just be careful when you multiply this negative 3 with the positive 1, it's becoming a negative 3. Alright, so we have got question 5. Towns A and B are 241 kilometers apart. Then something that should tell you that you are dealing with limits of accuracy is because after every sentence they say it's given correct to the nearest kilometer in this instance. And then the speed that John drives from town A to B of 120 kilometers per hour is also given to the nearest 10 kilometers per hour. So we are looking at a limit of accuracy here. So the next thing that they say, find the longest possible time. The longest possible time. So let me just underline that. The longest possible time means we are supposed to find the upper bound. Now you must be careful. The formula to calculate time is nothing but distance divided by speed. So when you are doing that, you have to find the upper bound of the distance. You divide that by the lower bound of the speed. Okay, so the upper bound of the distance, because it's the nearest kilometer, so 1 divided by 2 is 0.5, so you're going to add that 0.5. So the upper bound for the distance is going to be 241.5 kilometers. Then you find a lower bound for the speed, and it's given to the nearest 10 kilometers. So that 10 divided by 2 gives you 5 kilometers per hour that you are going to subtract, because you're looking for the lower bound there, because we're dealing with time equals to distance divided by speed. Right, so we have got 2.1 hours, but they want the time in hours and minutes. So change the 0.1 to minutes by simply multiplying by 60, giving you 2 hours and 6 minutes. So be very careful when you get these questions on limits of accuracy, that you don't look at things like, don't get confused with maximum or greatest or least, so that you can know whether you're supposed to do the upper bound or the lower bound of the given problem. And when the problem involves some kinematics, the distance, speed, and time, know the formula whatever you're trying to calculate. In this instance, we had time, which would be distance divided by speed. And because we are dividing, and when you divide and you want to find the upper bound, when you deal with a division question, you have to find the upper bound of your numerator divided by the lower bound of your denominator. Question 6, a regular polygon has n sides. Now this means all the sides of this polygon are going to be equal, and also all the interior angles will also be equal, each one of them. Now an exterior angle is given as 5n upon 2 degrees. So one of the things that you should know is that an exterior angle of any polygon, whether it's regular or irregular, all the exterior angles, they will add up 360 degrees. But here's something else that you should know. When you want to find each, so this is what I'm doing. I'm putting 360 over n. This is going to give you the exterior angle of a polygon. So if we know the number of sides the polygon consists of, suppose it's a 6-sided, then the exterior angle will be 360 divided by that 6, which will be 60 degrees. All right, so the 360 is the total angles, exterior angles, but to find each, it's going to be upon n. But now we are told that the one that we are looking for, its exterior angle is 5n upon 2. So we then create this equation where we take the general formula for the exterior angle equals to this particular exterior angle, cross multiply, you should end up with 5n squared minus 720. So this becomes a quadratic equation in n squared equals to 144. There are many ways you can solve this, or you can use the difference of two squares. Okay, because you should have two possible answers, and I am rejecting the negative 12 because there is no such thing as a polygon with minus 12 sides. So the correct answer should therefore be 12. So the value of n is 12, or the polygon has got 12 sides. Question 7, you are given that m raised to the power 2 over 3, n raised to the power of a third, all upon the cube root of m to the fourth power times n raised to the power of negative 2 should equal to m to the power p, n to the power q. We are requested to find the values of p and q. So basically, what is on the left here, you need to simplify. Okay, so first of all, then you realize that anything that is square root becomes then, yes, you're correct, it becomes a fractional index of 1 upon 3. But since that was a 5, it becomes 5 upon 3, and that was negative 2, it becomes negative 2 upon 3. The 0.3 is the cube root. Okay, so I'm dividing, so I'm therefore going to subtract the indices of the like terms, or the bases. When the bases are the same, m raised to the power of 2 over 3, I'm going to subtract it with the power of 5 minus all upon 3, and the same for n raised to the power of a third, I'm going to subtract it with 2 over 3, negative 2 over 3. Okay, so if you simplify and you clear it up, you realize that eventually you end up with m raised to the power of negative 1 multiplied by n raised to the power of 1, giving that p is negative 1 and q is 1. Question 8, so circle geometry. AB is the diameter of a circle, so AB, as you can see, and then the center is O, point C, D, and E, they lie on the circle, okay, C, D, and E, on the circumference of the circle, and then EC is parallel to AB, you can see with those arrows there, and AB is perpendicular to OD, so that is making 90 degrees here. So angle DOC is 38. Now you're supposed to find angle BOC. So if that is 38, these two angles are complementary. It means they should add up to 90 degrees because of the perpendicularness of the sides AB and OD. All right. So what we also know is that OB and OC are radii or radii of the circle. So the distance of OC and OB are therefore going to be equal. That information is very important when we look at the other question. So first of all, to find this particular angle here, we, as I said, it should be complementary. So subtract 38 from 90 degrees, and that gives you 52 degrees. So let me just bring in this information that I have so far. Now they want us to find angle CBO. That is angle CBO. Since you have the isosceles triangle, that is important, you can actually identify that each of these two angles, the base angles here, B and C, should equal to 64 degrees each. So angle OBC or CBO is equal to 64 degrees. Mind you, the same will apply to angle OCB, this one here. Right, then they want angle EDO. It's a 1-mark question, so sometimes it's not very easy to see that. So I'm bringing in a chord here. And the chord I'm going to bring in, I'm going to draw a line DC. This line is subtending, it creates, if you want to say that, the angle at the center. And an angle at the center, you should know that it's twice the angle at the circumference. So when I look at chord CD, or that arc CD, it creates this angle here at the center, which is 38 degrees. It also subtends the angle there at E, which is going to be half of 38 degrees, which is 19. So if I bring that little triangle in here, now I have 19. But we're looking for EDO. We're looking for this particular angle here. Since we now know this is 19, and we know this is 90, the angle sum of a triangle should add up to 180 degrees. It's easy for us to calculate that missing angle. So EDO is going to be 71 degrees. So sometimes you have to work with your pencil on the diagrams and try to draw arcs and see and chords and see, especially if things are not so clear. Right, the map shows part of a golf course. A golfer hits a ball towards the flag. So he hits the ball towards the flag. Now, then they also say the path is always the same distance from A and B. Very important when you're told that the same distance from 2 points. When you're given 2 points, same distance, we are looking for something equidistant. So when you are describing and you're given 2 points in capital letters like A and B, and you have the word between, all right, so that already tells you, we have the word and, like A and B. That tells you you are looking for the perpendicular bisector. That is the line that you're going to draw. You're going to bisect the perpendicular bisector of AB. That means you're going to draw a line that is the same distance from A and B. For that, you need obviously a ruler and a compass. So this is basically what you would do. You'll open your compass at a slightly more than half the distance of line AB, and you can just look at that or do that by inspection. Then you open that particular radius. The reason why you are opening slightly half the distance of the line is because you're going to use that same radius. You're going to put that compass also at A, and you're going to use that same radius so that the two arcs can intersect. And you then use your ruler and you draw the line where those arcs intersect. So it's just a ruler and a compass for this question. So eventually your line should be something like that. So this is the path that the golf ball travels. It doesn't go to the flag, it goes here. The distance on the red line is the same distance from point B and from point A. Question 10, the variables x and y are connected by the equation y equals to k times the quantity x plus 1 all squared, and then they say k is a constant. So you have got a table here with corresponding values. You have an x value which is 3, and then you have a y value which is 32, and so on. Right, you're supposed to calculate the value of k. Now, to calculate the value of k, it will be better that you pick the one that is complete. Okay, so for x there is 3 and y there is 32. So bring back this equation. And now you substitute for x and you substitute for y. And your objective now becomes simple. You then calculate the value of k. In this particular case, k will equal to 2. Right, now you were supposed to calculate the value of m. Remember, you calculated that k for a reason. So this is the value of m. M is now, in our equation, m is now the value of y. So I'm going to write m for y. So I'm going to say m equals to 2, which is the value of k that we calculated previously. And in brackets, the minus 1 is the value of x that I'm getting from the table, corresponding with the value of m, of course. All right, substitute that into that. You will obviously realize that m is equal to 0, hence 1 mark question. Now, when you are coming to the part C, it says the possible values of n. It's plural, okay? And also, in the answer space for higher level, they are indicating here that you have 2 possible answers. So something becomes quadratic. So bringing back the table, this is the possible values of m that we are looking for. Right, I'm going to substitute n, and the 2, remember, comes from my constant that I calculated before at part A, and 8 is the value of y, which is now in the place of the 8 here. Right, so play around, divide by 2, okay, or whatever method you use. Get rid of the square by taking the square root. Square root of 4 is going to be positive or negative, so you have 2 solutions. So it's either the square root of 4 is positive 2 or the square root is going to be negative 2. Then you have 2 possible answers. Solving for n gives you n equals to 1 or n is equal to negative 3. So read the questions carefully. Question 11, the position vectors of k and l relative to the origin. O are OK, which is given 16, 2, and OL is 4, minus 3. Points M and N are midpoints of OK and OL respectively. So you're supposed to express MN as a column vector. Very important that you understand. I'm going to do this question also by bringing in a diagram. So first of all, OM, as we know, is going to be half, because the midpoint of OK will be half of whatever OK is. OK is 16, 2. So half of that is 8, 1. So that's going to be my distance O to N. And my distance O to N will be half of what the distance of O to L is, which is 2, negative 1.5. Now, this Mn is a displacement vector. So what you do is you take the second point, position vector, minus the first point, position vector. So if I have Mn, you take the second point, which is the n, so you say On minus the first point. So On, we calculated as nothing but 2 upon negative 1.5 as a vector, and Om, we calculated as 8 upon 1. So now, you simply now take the quantities there, the 2 minus 8, subtract a negative 1.5 minus 1. All right, so that gives you that the displacement vector Mn is going to be equal to minus 6 upon minus 2.5. Right, so also, as I said, do your revision on vectors, and I hope that this question is straightforward. So let's look at the diagram, how it will look. So this is my diagram. So from O to K, it's from the origin. Position vectors, they start from the origin. If they don't start from the origin, we call them free vectors, but these are position vectors, O to K. So if you are given a point K, and they are saying to you that as a coordinate, K is nothing but 16, 2. As a vector, this can be written as O from the origin, K, okay, position vector, you can write it as nothing but 16, 2, okay? So that is that trajectory it takes. And the same applies from OL. So when you're given L as a point, 4, negative 3 as a coordinate point, as a vector, it becomes OL from the origin. It's a position vector. It will therefore be nothing but 4 upon minus 3 as a vector. Right, so the midpoint is clearly indicated here. You can see that the midpoint is clearly visible. Here the midpoint is nothing but, as you can see, 8, 1, okay? And here the midpoint is nothing but 2, slightly halfway between minus 1 and minus 2. When you are talking about the distance or the position vector from M, or the displacement vector from M to N, is you're going in this direction because you're going to the left. So when you count, it's 1, 2, 3, 4, 5, 6. So that's minus 6, what we had before. And then you go down, so it's going to be negative again. So that's 1, 2, 2,5. So it's minus 2.5. All right, this is how it will appear otherwise on the diagram. So when you don't have, you're struggling with the displacement vectors, it will be helpful if you can maybe draw yourselves a quick sketch and try to see how these things will behave. Right, so here we are finding the modulus of the vector. We find the distance of KL, right? Again, so you know the formula. You take the two y values, subtract them from each other, the two x values, subtract them from each other, the squares. It basically becomes something that has to do with Pythagoras. Again, I'm going to bring in the diagram so that you can see how did we arrive at the answer of 13 units if, for example, you've forgotten the formula. This is my diagram if I bring it back here. So let me draw the line KL. So I need to make a triangle. Pythagoras theory comes in handy. I'm looking for the distance of KL. To find the distance of KL, let us determine what are these values here. This is 5 units here. Make sure that your scale makes sense. And this is 12 units here if you count them. So this is a right angle triangle. So we can now calculate the hypotenuse by simply saying that a hypotenuse, when you square it, should equal to the sum of the squares of the two shorter sides. That should give you that KL squared is equal to 169. Therefore, KL will be nothing but the square root of 169, which is the positive value because we're looking for a distance, and distance should be positive, giving you 13 units. So basically, essentially, when you calculate the modulus of a vector, you are calculating the distance from K to L. So you can't use your ruler and measure. You see where Pythagoras comes in. Question 12. Well, there are two parts to this question. The first part, they say shade one square in each diagram so that there is, so this is the first one line of symmetry. Well, if I shade that particular block there, and this is my line of symmetry, okay, this line is like a mirror line, and if you fold it on this line, whatever is on the left is going to be superimposed on the right if you fold it. So that could be where that square is. But I also pick a different one. If I put the square here, can you see that? There is also one line of symmetry if you fold it horizontally on that mirror line, so to speak. So there are two possibilities. If you don't agree with this question, please feel free to give a comment in the section or get in touch on my Google Classroom. Right, then the second part, they say rotational symmetry of order 2. So I've shaded this one here. So I'll just show you how when I turn it 90 degrees, that's where it's going to be. So it doesn't appear the way it is. But if you turn it again 2 times, then you get that it will look exactly the same. So that red comes to where that is. So the shapes technically are the same. So this is the correct shape. This is the block that you needed to shade. Question 13, two similar bases have heights which are in the ratio 3 to 2. That's the corresponding ratio of the sides. The volume of the larger vase is 1080 cubic centimeter. You're supposed to calculate the volume of the smaller vase. Right. So basically you're dealing here with similarity. Since you are dealing with volume, you take the heights that you're given and you cube it. All right. It's not area, but it's the corresponding sides. And if you do that, I get 27 upon 8. You're going to compare that now to the larger, obviously comes on top, and the smaller one will be the one that we're looking for, as you can see with the corresponding k here. Right, so simply cross multiply, solve for x. That should give you 320 cubic centimeters. Again, you probably have a different way to get to the answer. Bottom line is you are dealing with volume, and you should be careful. Question 14, a lady golfer from Walvis Bay plays a particular hole many times in a year. On 30% of all days, there is a wind blowing across the course. If the wind is blowing, the probability that she hits a straight drive is 0.2. But if the wind is not blowing, the probability that she hits a straight drive is 0.7. Reading that question like that can be really confusing. So you need to bring in sort of a diagram to understand what this all means. So we have to find, first of all, the probability that on a particular day, the wind is not blowing and she hits a straight drive. Right, also I get some key revision. When you have and, it means multiply. And also 30% that they are talking here is nothing but 0.3 as a decimal. And 70% therefore will be nothing but 0.7. Right, so this is how I made my 3 diagrams. So I had wind blowing and no wind, and then straight drive and not straight when she hits the golf ball, and when there's no wind, then the straight and also no wind, not straight. So let me bring in the values that I have. So I know 0.3 is when there's wind. So I also know that 0.2, the wind is blowing, and then she hits a straight drive. Then obviously the 0.7 you calculate because this when you go along here, should add up to 1. All right. The 0.7 that I get here is when the wind is not blowing, no wind, and then she hits a straight drive. So I can go ahead and fill in the rest because, as I said, 0.2 plus 0.8 should give you 1. 0.7 plus what should give you 1? Obviously 0.3. So now I have the information. So we are looking for the probability that on a particular day, the wind is not blowing, so go to no wind. That is 0.7. So when I go along the branches, we multiply. No wind, and she hits a drive. No wind times the straight. So 0.7 times 0.7. So obviously that answer is nothing but 0.49, okay, as a decimal. Right, let's go to part B. So let me just bring my diagram back. So they say she hits a straight drive. So when she hits a straight drive, this is very important. It can be when there is wind or no wind. When there is wind, we have 0.3 times 0.2. And so we're going to add now. When there is no wind, times the straight that we've calculated before. So eventually, you should get 0.55. So this is when she hits straight drives. That's the probability. Okay? Should be between 1 and 0. Find the probability that or question part says she plays the hole on 2 successive days. Okay. Find the probability that she does not hit a straight drive on either. So first of all, when she does not hit a straight drive, it's 1 minus when she hits a straight drive, 1 minus 0.55, which gives you 0.45. So this is what I'm going to work with. So I'm going to write it as 0.45 raised to the power of n, where the n represents the number of days. Since they are saying 2 consecutive days, just then square that answer, and the answer is 0.2025. And that is what the answer should be to this particular question. Again, it will be quite tricky to try to solve this question without drawing yourselves a diagram. Question 15, the table shows information about the time, T in minutes, taken by 80 girls to complete their mathematics examination. Right, so they are saying on a histogram, so you are not allowed here, they don't say you must draw the histogram, they didn't give you information like that. They are saying the height of the column for the interval 60 to 80 will be 2.8 centimeter. So we have to calculate the height for the column between 80 and 120. Now, what you need to understand is you need to bring in your formula that frequency density is equal to the frequency divided by the class width. Now, when you do this, in this particular case, I'm also going to work out the class widths. Now, it's very easy. You just say 60 minus 40. That gives you that class width for when there are 5 learners, all right, who complete the tests below 60 minutes. And then 20 will be the next one, 80 minus 60, 120 minus 80 is 40, 150 minus 120 is 30. So what I have up there is my class width. And this is what you do also. All right, so I have a table, an extra table that I brought in here for the frequency density. So when I'm calculating the frequency density, and if I take the interval that I have between 60 and 80, if I take the frequency of 14 and I divide it by the class width of 20, I'm getting 0.7. But I should get 2.8. So there is some constant that this 0.7 is multiplied with to give me 2.8. So we need to find what that constant is. And we simply say 2.8, what we are given in the question, we divide it by that 0.7 in order for us to find that constant by which we should multiply to get the given height of the column. So for example, in this particular case, if you take the frequency, which is 14 over 20, and I multiply it by that 4, I get nothing but 2.8. So therefore, I can now do the one between 80 and 120. So when I do that, I take the frequency of 32 over the class width of 40, and I multiply that by the constant. That gives me that is going to be 3.2 centimeters. Right, so you can pause here, and maybe you can try to calculate the height, the frequency density for the intervals 40 to 60, as well as the intervals 120 to 150. Right, so this is expected. This is the answer to expect. They didn't really require you to do that. I just decided to do it anyway. Part B, we're going to talk about the modal interval. So modal class interval, and it's going to be quite useful. Part B says write down the modal interval. So what does all that mean? So the modal class or the modal interval. Now, when you have the following conditions, if the classes have the same width, say suppose you do that and the classes are the same width, the modal class where the majority of learners would be, or the data, is going to be the one of the highest frequency. But now, this is not the case for this particular case, because we had different widths. So the modal class or the modal interval is going to be the one with the highest frequency. And that is why I brought in the table here with the frequencies. And you can quite clearly see from my table here that between 120 to 150, that class there has the highest frequency density. Therefore, it is the modal interval. Okay. So that is quite useful that you had to calculate the other two as well, not just the 2.8 and the 3.2, 2.8 you were given, but also the one here and the 3.9, roughly about 3.9. Right, don't forget to subscribe to the channel. This is Sankofa Mathematics. You hit the notification bell so that you can get updates every time if I post a video. So we have got question 16 here, 3 numbers x, y, and 25. They have a mean of 27. That means if you add these 3 numbers and you divide by 3, you get 27. So basically, you then have to solve for x and y. So multiplying by 3 gives you x plus y plus 25 is equal to 81. So x plus y is equal to 81 minus 25. So 81 take away 25 gives you nothing but 56. So x plus y will be 56. Right. Part 17. So you have a diagram. It shows a rectangle, as you can see, ABCE. And then you have a right angle triangle, and then you have a sector here, part of a circle with 30-degree angle here. Okay, and then you have a shaded part there as well. So first of all, they say you're supposed to calculate AE. Now, AE, you just have to look at that. It's a right angle triangle, so you can use your ratios because you have an angle and you have a side, the hypotenuse. You have an angle of 60 degrees, you have the hypotenuse of 8 centimeters, and you're looking for AE, which is adjacent to this angle, so the cosine rule or the cosine ratio comes in handy. The cos of 60 degrees equals to AE, that distance we're looking for, upon the hypotenuse. You manipulate, you should get that AE is equal to 4 centimeters. Right, then they say calculate the area of the sector DAB. So let's just bring in what we can. So first, the area of the sector. The area of the sector will be, remember it's part of a circle, and the area of a circle is pi r squared. So this is not a complete circle, by the way. It's 30 over 360. Basically, it's 1/12 of a circle, or 30 upon 360 times pi times the radius, which is 8 centimeters. You're given, and you can see from that information, the radius is 8 centimeters. It's also 8 from A to D, 8 from A to B as well. Manipulating this gives you the area, which is 16 upon 3 times pi, or you can just give it roughly as 16.8. Correct to 3 significant figures. Please remember, you're rounding. And also, you can leave the answer as 16 upon 3 pi, which is actually the exact answer. And the answer is not going to be exact because the value of pi is an irrational number. So when you round, you should be specific and you should justify your rounding. Follow the instructions in front of the question paper. Right, they are saying we're supposed to calculate the area of the shaded part. So what you've seen here, I also wrote down the area of the sector that I've calculated from my previous question. But I can calculate the area of this triangle, which you can calculate by using the formula a half times AB times the sine of C. All right, so that is going to be half times 4 times 8, the side's flank there, times the sine of 60 degrees. That gives you 8 square root of 3. So I'm leaving it in third form. So now I'm going to calculate the area of the whole rectangle. And I'm going to subtract these two from each other. So I've done it on the side, eventually leaving me 1.39 to 3 significant figures. All right, so you see that I use thirds, and the answer in terms of pi is easier than to go and round here, because premature rounding can lead to it can affect the integrity of your answer. Question 18. Now first I put this question here so that you can first see. So the diagram shows the frame of a toy bicycle made from 5 metal rods, and then ABC is an isosceles triangle. As you can see, those dashes there are indicating that AB is equal to AC. And then you have got the base is 22 centimeters and the base angles here is 50-50. So actually that angle can be calculated as 80, because in triangle ABC, angle A will be nothing but 80, because they should all add up to 180. Then angle ACD is equal to 100 degrees, as you can see, and CD is equal to 31 centimeters. So what is important? We are supposed to calculate AD, but we should give it to the nearest whole number. So remember that when we are dealing with our question here. So there's going to be sine and cosine, or you can drop a perpendicular from A, cutting that 22 in half. Then you have the right angle triangle where you can have 11 and a 50 here, and then you use your ratio to calculate the value of AC. Or you can also use the sine rule or the law of sines. Right, so if I just bring in what I need to do, first I'm going to find the value of AC. I have my 80 here, and then I'm going to use the sine rule. AC upon sine of 50 degrees, remember it's opposite, equals to 22, which is this distance, upon the sine of 80 degrees. So AC should be on its own by multiplying throughout by the sine of 50 degrees. Basically, you are getting AC to be 17.1129621 and so on centimeters. right? So that gives me the distance of AC. So now if I bring just this little part here of the triangle, because I'm looking for AD, when I have two sides at an angle in between, I'm supposed to use the cosine rule. And the cosine rule is that distance squared is equal to this distance squared plus this distance squared minus 2 times this distance times that distance times the cosine of 100 degrees. Use your calculator, please, because you can easily make mistakes. AD will be the square root of nothing but 1438.094822, which gives you about 37.922, and so on and so on. But remember, we're supposed to give our answer to the nearest whole number. That is why I highlighted that particular part in the beginning. So the answer, therefore, will be 38 centimeters. Question 19. We have got circle geometry here again. If you want to, or coordinate geometry, points A, as you can see, negative 8,2, points B, negative 2,6, point D, which is on the y-axis, is 0,8. They are vertices of a triangle that lie on the circumference of a circle. The center of the circle, M, and PD, also you're told that it's a diameter of the circle. Calculate the coordinates of M. Well, you can calculate the coordinates of M by taking the average of the x values and the average of the y values. Very simple and very straightforward. So x is going to be negative 1 and y is going to be positive 1, as you can see. In that quadrant, x values are negative and y values are positive. Right, then you're supposed to show that the equation of the line parallel to BD. So let me bring in so you can understand. If we're talking about that line here, the gradients of parallel lines are equal. So whatever that gradient is of that line, and I've calculated it here, it's 7. This line that is going to touch here at A is also going to have the same gradient. So it's going to be a line that takes y equals 7x plus c. So the objective is to find the value of c. So the value of c is calculated by substituting the point A, because it is passing through that point, into here for x and for y. So y being 2 and x being negative 8 all clears up to c being 58. So rewrite it in that form. Therefore, we prove that y is equal to 7x plus 58. Part C, find the equation of the perpendicular bisector of line BD. So let me just bring in a story here. If you are dealing with straight lines and you're told it's perpendicular to each other, it means whatever the gradient of BD with the gradient of this line that I'm going to have here, their gradients are going to be, you multiply their gradients, you get negative 1. So, but we know what the gradient of BD is. We know that it's 7. So the other one's gradient should be negative 1 over 7. It should be a fraction that is the inverse, the reciprocal of the other one, plus with an opposite sign. So that one is 7, so the opposite sign should be negative, and also a fraction that is the reciprocal of that. So 7 upon 1, the reciprocal of that is 1 upon 7. So we know now our equation will have y equals to minus 7 over x, or 1 over 7x plus c. Right, so we can also use the same methodology like we did in part B. We want to find the value of c by simply substituting that midpoint, because this point here, negative 1, 1, both these lines are equal. They are intersecting there. So they will have exactly the same x value, and they will have exactly the same y value. Substituting that gives you that c becomes 6 upon 7, right? And when you clean this up, now when you are here, you multiply by 7 and get the x on the other side and the 6. Eventually you should have x plus 7y minus 6 is equal to 0, because that is the form where they want your equation to be. And a, b, and c are integers. And remember, integers are positive or negative whole numbers, including 0. Right, question 20, you have a diagram here, shows a triangle ABC in which A is the point 5,8, B is the point 2,4, C is the point 9,6, and then I also have a point X here which is 2,2. All right, and you must make sure your scale here, you can see that there's 5 little blocks between, so each block represents 1 unit in both axes. Right, the following transformations can be applied. So we are dealing here with repeated transformation. So there's a P, which represents a reflection in the line y equals to x. There's a transformation Q, which is translation by that given vector, negative 3, 7. Then we have R, which is a rotation clockwise through 90 degrees up on that point, about that point that is given there. Right, so for part A, they say, find the image of B. So this B here, when transforming it, transformation Q is applied. So first, when we transform from B, the Q, we have to move it in a vector. Negative 3 to the left and 7 units upwards. I expect you to be all the way up there, but you are not done yet because there's another transformation that follows. And that transformation is P, which is a reflection. So let me bring that line in, y equals to x. So the reflection of this is going to be, and it's very interesting, whatever the point is of this line, right? If you don't count, so I'm going to give you, let's say, what that point is so far. So that point is negative 1, comma, and it's negative 1, comma, 11. That's what that point is, negative 1, comma, 11. All right, just make my 11 nicely here. So its reflection, well, let me just go back and rewrite it again. So the point I'm dealing with is negative 1, comma, 11. And it is in the second quadrant. So you expect that reflection to be somewhere, all right, in the fourth quadrant. So in the fourth quadrant, all that you will do is you are going to change these coordinate points around. So it's going to be nothing but 11, comma, negative 1. That's the beauty of it. All right, and that's where that final answer would be, 11, comma, negative 1. Or you can count if you want to. You can count to see how far this is away from a given point. Okay, you make that L shape, or how far this line is. Well, if you count from here, and you're going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 units away, or should be 11. Okay, maybe my counting wasn't so proper. Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 exactly. That's how you can find it. All right, but that is where the final point would be. So repeated transformation. First you do the first part, which is you translate it by a given vector, which is negative 3, 7. That's why it's all the way up there. Then you then have to bring in that line y equals to x and find the reflection, and that will be the final answer. Right, still the same question. Find the image of point C when transformation R. Now transformation R is nothing but the rotation about this point X, which is 2, 2, and it's in a clockwise direction. So we're going to take this whole triangle and we're going to rotate it clockwise. Well, so I have done it, and that's where I'm going to end. All right, so the value of C, or the coordinate of C, is nothing now but negative 6, comma, negative 5. Negative 6, comma, negative 5. Okay, so we have to make sure, maybe you're counting, and maybe you are, whatever method you are using, you should get to that same particular point. Question 21, the speed time graph shows a car comes to rest in 7 seconds. The part of the graph labeled PQ is a straight line, so from there to there is a straight line. Now they say calculate the deceleration of the car between t equals to 2 and t equals to 4. So we are looking for whatever that line is, the rate of change, that gradient. So we can calculate that gradient by finding what is the y value. So it's 8 minus 3. That's 5 units there. And what is the unit here? So because gradient is, remember, gradient is the rate of change, is deceleration. Acceleration is calculated the same way because the line is sloping downwards. That's why it's deceleration. So I've got 5 meters per second divided by 2 seconds. All right. So eventually that's going to give you 2.5 meters per second squared. Okay, which is the answer to this particular question. So when you have deceleration and acceleration, think about gradient. How do you calculate gradient? Delta y over delta x. Now the distance between t equals to 2 and t equals to 4. Now we are dealing here with the area under the graph. That is what you should remember with speed time graphs. To find the distance, it is the area under graph. So here it's very easy because this is a triangle. And the area of this triangle, you can calculate it half times 2 times 5 is equal to 5. Okay. Then there is also another part, a rectangle here. The area of that rectangle there. That's 3 times 4 or 3 times 2. And that gives you 6 meters. So the total distance will be total of this 5, and that's 6, which is nothing but 11 meters. Part C, the speed of the car in kilometers per hour, it's bolded. So when t equals to 0 here, when t equals to 0, the speed is in 10 meters per second. So our job is to change it in kilometers per hour. Right, I know that I'm going to divide by 1,000 because 1 kilometer is equal to 1,000 meter. And here, 1 second, if I write it in terms of hour, I'm going to divide 1 second by 3,600. This already should give you right upon the correct answer. 10 divided by 1,000 gives you 1 over 100. Divided by 1 divided over 3,600. Take the reciprocal of that, clear that, you should get 36 kilometers per hour. Whatever method you use, you should get this answer under 2 minutes because it's only worth 2 marks. The last question here, triangle ABC is isosceles with AB equals to BC. Very important point. Side AB is C, BC is A, which these two sides are actually equal, and side AC is B. Right, so those two sides are equal. So also that A equals to C. So where I have a C, I will replace it with an A. And then I'll prove this business here. Cos B equals to 1 minus B squared upon 2A squared. Right, so that's exactly what I do here from my cosine rule, cos theta. I hope you still know that, A squared plus. Now I'm going to use A squared here because the two sides are equal. Minus B squared upon 2 times A times A. Alright, now clear that up. A squared plus A squared is 2A squared, and 2 times A is 2A squared. Put everything over the same denominator. Then this is going to become nothing but 1 minus B squared upon 2A squared, which is what was required. Right, so I hope that these 52 or so minutes really assisted you to go through the questions. Where you get stuck, I'll ask you to revisit, pause the video, and good luck with your studies. Stand by for paper 2, higher level of 2020.